In this video, let's check your understanding and do some problems where we're using this heat of reaction from the thermochemical equation as a unit conversion factor and trying to see how much energy is going to come out with different amounts of reactants or products being produced. Okay, so let's use our old standby, the hydrogen reacting with O2 to give water. The heat of this reaction is equal to negative 241.8 kilojoules. So let's start out easy. Let's say we have 1 mole of hydrogen. How much heat is going to be released per 1 mole of hydrogen gas? Well, we have 1 mole of H2, let's say, that's what we're questioning. And then we know that my heat of reaction is in units of kilojoules per mole of, per x moles, whatever the stoichiometric coefficient is, of that reactant. So my heat of reaction is 241.8 kilojoules, and I have 1 mole of hydrogen in my chemical reaction. So my heat of reaction when 1 mole of hydrogen is consumed is going to be negative 241.8 kilojoules. All right, now let's take another little step forward and say, well, let's try to calculate the heat released when 1 mole of oxygen is consumed. So we'll start like we did before, 1 mole of oxygen. And then looking at my thermochemical equation, I have negative 241.8 kilojoules per 1/2 mole oxygen, so I'll say 0.5 moles of O2. And so I'm essentially going to get out twice as much, is going to be negative 483 rounded, of course, kilojoules. Okay? So you can see how we're taking this and applying the units of per x moles of whatever reactant, or maybe now we'll look at the products. Let's say my next question is to essentially do the opposite of this reaction. Let's take water and 9 grams of it, 9 grams of water, and convert that into hydrogen and oxygen gas. Okay, so let me get you started here. We'll take water gas and produce H2 gas and 1/2 O2 gas. And I want to know how much heat will need to be applied, right? We know that heat is released when we do the opposite, and so delta H here is going to be plus 241.8 kilojoules, and I want to know about 9 grams. So tell me how much heat is going to be consumed when 9 grams of water is converted to hydrogen and oxygen. The first thing that we need to do is to get on that mole train. We know that we have units of kilojoules per mole from our balanced thermochemical equation, and so we need to get from mass of water to moles of water. So 9 grams divided by 18 grams per 1 mole means I'm going to have 1/2 a mole of water. Okay, and then 1/2 mole water, looking at my equation here, I have, or well, rather here, because we're talking about the decomposition of water. So we're talking plus 241.8 kilojoules per 1 mole of water used. So I'm going to get out 120.9 kilojoules as an answer. And this is a positive value, so I need to put in 120 kilojoules of energy in order to take water into hydrogen and oxygen gas. And we can actually do that. We can split water using electrolysis. We can apply an electric current, and that energy, that electrical energy, can break these chemical bonds and produce hydrogen and oxygen. Thanks for watching.